Good morning, all of you. Yesterday lectures we finished the synthesis of nanomaterials methods, that is the hydrothermal methods and chemical vapor deposition methods. So today we are going to discuss the examples of chemical vapor deposition methods. So yesterday we just understand what is meant by the chemical vapor deposition method. So the chemical vapor deposition method, it is the method which is used to prepare a nanomaterial by using it is a simple coating process, okay, in presence of thermal or the heat or high temperature, high pressures, and that this chemical reaction, it is only induced by the heating or the thermal conditions, and this chemical reactions which is presence on the uh, surface materials. So whenever it is a some substrate or the surface, and then we passing some gases or the mixture of gases, and then they get absorbed and doing some reactions over the surface area and the substrates. So that heating and the high pressure, low pressures, or high temperature or low temperature, so that is the effect on your substrates. So with the reagent supply or whatever the reactions we want or what kind of a product we want, so that kind of a mixtures of gases or that kind of a substrate we can place into the chemical vapor deposition chamber. So that type of the starting materials or the substrate materials itself doing some reactions, and they got the product like nanomaterial scale level, right? So this methods also, it is a vacuum depositions methods. Depositions म्हणजे काय तर एका सबस्टेटवर दुसरा केमिकल सबस्टन्स हा काय होणं, कोट होणं किंवा त्याला कोटिंग होणं. सो अशा पद्धतीचं, पण हे कोटिंग होत असताना किंवा हे जे प्रोसेस होत असताना केमिकल रिएक्शन, तिथे टोटल सीव्हीडी चंबर हा काय असायला पाहिजे, व्हॅक्यूम असायला पाहिजे, म्हणजेच तिथे कुठल्याही पद्धतीचा गॅस नसायला पाहिजे, राईट? सो एअर नसायला पाहिजे. गॅस म्हटल्यापेक्षा आपण त्याला एअर म्हणूया. एअर तिथं जर नसेल, सो we remove all the airs and we can fill up the gas like a nitrogen. So that is a, if it is fill up the nitrogen gas over there, so your CVD chamber, it is vacuum. So this is also called as the vacuum deposition methods used to produce high quality and high performing nanomaterials. Solid nanomaterials can be prepared. So this is the simple process we just understand yesterday. What do you mean by the chemical vapor deposition methods? It is a simple process which will be formations of a solid materials by the deposition methods or by the deposited form by passing the vapors and doing some chemical reactions on the surface or the substrate area which is present in a CVD chambers, right? So this solid materials obtained by coating. आता हा जो सॉलिड मटेरियल किंवा नॅनो पार्टिकल्स किंवा नॅनो मटेरियल्स आपल्याला जो मिळतोय, तो एकतर तो सॉलिड असतोय आणि तो कोटिंगने मिळतोय किंवा पावडर फॉर्म मध्ये किंवा सिंगल क्रिस्टलाइन फॉर्म मध्ये सुद्धा आपल्याला तो मिळतोय. ओके, so these are the type of product which will be obtained after the CVD reactions or CVD methods, right? By varying the experiment. So yesterday we also discussed this the factors like experimental conditions. So the experimental conditions, substrate materials, substrate temperature, composition of the reaction mixtures, total pressures, and their flow. So these are the factors which affects your chemical reactions, and that chemical reactions which will be affects your synthesis of nanomaterials in a CVD methods, right? So and if the nanomaterial is different, their properties also will be somewhat different, right? So this is all the factors which will be we called it is the affecting factors on your nanomaterials in a CVD methods. So these are the some steps which will be involved in the CVD methods. what will be the steps? That is the transport of reactant. जे काही रिएक्टंट असेल, आपण जे काही पास करतोय गॅस, तो जो इथून गॅस पास करतोय, हे आपल्यावर डिपेंड आहे की आपण कुठल्या मिक्सचर्स, कुठला गॅस इथून पास करायचा आहे. इट इज टोटली डिपेंड्स अपॉन यू. So this transport of the reactant which via force conventions to the reaction regions. So this is the reaction regions. We kept over here the substrate materials, and when you passing the reactant from this one and reaching out this one. So this is an examples which will be reactions occur over here, and some unwanted materials or unwanted gas which pass, it is removed from this chamber, right? And this is the steps. And then second one is the transport the reactant via diffusion. So diffusion means just the when it passing through the gas from this chamber, so some of the gas molecules are deposited, or it is absorbed on the surface area. So this is a simple diffusions. And then uh, remaining the gas which is not used in this one, or the some other materials or in the form of gas will be diffused out. Diffused out means the gas is spread over from the higher concentration to the lower concentration. That is the meaning of diffusions. Then adsorb reactants on a surface. This one is the adsorb on the surface area. This surface process, it is a simple chemical decomposition of surface migration sites, or the process or incorporation process. Desorptions of the byproduct. Some this like byproduct will be formed and it can be desorbed. Desorb means the remove the unwanted unwanted materials which will form on the substrate, which can be removed from the substrate, right? So that is a desorption process. Okay. The transport of this byproduct through these chambers, ह्या चंबर्स मधून किंवा बाउंड्री मधून आपण त्याला बाहेर काढतोय because of the diffusion process, or sometimes we are increasing the flow of a gas, right? So these are the steps are involved in your the CVD's process. Okay. Here CVD chamber, it is just like this. So here is the your pressures which will apply, and oven here is, this is the simple oven that is having some temperature control is there, and what kind of a temperature, what temperature if you want for the your reactions, we can control over here. This side we can pass the gas, any gas, so like your carbon, hydrogen, nitrogens, or any gas, argon, something like this. Okay, so we can pass over here. And here your substrate or the sample cords boards. And when you place the sample over here and passing the gas, some reaction is occurring, and then pass out the unwanted gases from this outlet, right? So this is the simple figures of your CVD chamber. CVD chamber अशा पद्धतीने असते. So these CVD methods are also, it is classified. We discussed yesterday. That is, it is a classifications on the basis of their operating conditions, or operating how this CVD chambers we can operate with the help of these different conditions. So, for example, atmospheric pressure. So then CVD methods we called it is the APCVD. If it is a low pressures, you are doing the reactions at low pressure. So that time we called it is the LPCVD. If you doing the reactions in a CVD chambers like ultra high vacuums, so that time we can say that UHV CVD. And we are using the subatomic atmospheric natures of the CVD, that time we can SACVD. So these are the classifications by operating systems. So that time we say that this is the LPCVD or APCVD. So on the basis of this, we can classify the on the basis of operating conditions, we can classify the CVD methods like this, right? So now the exact examples of this one. This is the examples of CVD methods to synthesis the polysilicon. So we want to decide product of nanomaterials like polysilicon. So this polycrystalline silicon is deposited from trichlorosilanes or the silane materials. So the pure silane materials or the trichlorosilanes. So when you doing this reactions in presence of gas, okay, when you pass the gas, so this reaction is occur in a low pressure CVD, low pressure CVD. हे जी रिएक्शन्स आपण करतोय त्या रिएक्शनच्या वेळेस आपल्याला लो प्रेशर सीव्हीडी म्हणजे लो प्रेशर यूज अप्लाय करायला पाहिजे. And with either pure sealants or some solutions of sealants with a 70 to 80% of nitrogen gas which will be passed through the chamber, and the temperature between of these reactions 600 to 650 degrees Celsius, and the pressures between these 150 pascals up to this, and the yield of the growth rate between this is 10 to 20 nanometer per minute. म्हणजे ही जर रिएक्शन कंडिशन असेल तर तुमचा पॉलिसिलिकॉन हा 10 ते 20 नॅनोमीटर एका मिनिटाला अशा पद्धतीचे हे नॅनोमीटर साईजचे पॉलिसिलिकॉन्स नॅनो मटेरियल्स तयार होतील. But if you change the reaction condition over here, for example, an alternative process uses hydrogen-based solutions. Hydrogen-based solutions, जेव्हा जर तुम्ही use करत असाल. So instead of the nitrogen gas, if you pass the hydrogen gas through this, that time the hydrogen reduces the growth rate. Okay, so this is the affecting factors of your synthesis of a nano materials of polysilicons. जेव्हा तुम्ही नायट्रोजन पास करताय त्यावेळेस तुम्हाला एका मिनिटाला 10 ते 20 नॅनोमीटर साईजचे जे सिलिकॉन्स मटेरियल्स तयार होत आहे नॅनो मटेरियल. बट if you use the instead of nitrogen gas, if you use the hydrogen gas, so that time the rate of this synthesis will be decreases, so it is reduces the growth rate. But if you using continuously hydrogen gas and if you increase the temperatures, that is from 650 to 10 1050 degrees Celsius, if you increase the temperature, so that time polysilicon may be grown directly with the dopant. So this is will happen, or this is the factors of temperature, factors of the gases which will be passed to the CVD chambers, and the percentage of your gases and their flow. It is very important to play a role play to synthesis of nanomaterials in a CVD methods, right? So if a gas such as a phosphine, arsenic or diborins are added into the CVD chambers, so that time diborin it is an the gas which is increase the growth rate also. But arsenic and phosphine like a gas, it is decreases the rate of your nanoparticles or nanomaterials, their synthesis. These are the affecting factors to affect the synthesis of nanomaterial in a CVD methods. So this is the examples of your uh, synthesis of nano materials like polysilicon in a CVD methods by using of a CVD methods. Okay, so these are some examples put over here, and just like your the CVD chamber. So this is the SiO2 and silane, or this monolayer of this one, and its growth of when you pass this here is the substrate, that is the MOS2, and when you pass this gaseous materials to this, and it is formations of just like your MOS2 and MOS AC2. So this is the heterojunction material will be formed in a CVD chambers. So this is again the second example, that is a sulfur or selenium. Argon gas is passed, and here with sulfur and selenium is one of the substrates. Second one is the WO3, and third one is the MO source. So these are the 1, 2, 3 substrates who are kept over here, and these three substrates, when you passing the argon gas, it comes to the different types of the materials will be formed over here. So this is an examples of, here is the source of sulfur, here is the source of AU nanoparticles, and here is the source of the molybdenum oxides. So three substrates are over here, and when you pass the nitrogen gas through these chambers, it will formations of the different types of materials like over here. So this is the different types of, this is your the gold nanoparticles. This one is your sulfur, and it is coating with this molybdenum oxides. So this type of the material, nanomaterials, or will be formed with the help of different reactant materials or substrate in the CVD methods. So all these are the methods or the examples used in the uh, synthesis of a nanomaterial in a CVD method. CVD methods ह्या अशा पद्धतीने आपण वेगवेगळ्या पद्धतीचे नॅनो मटेरियल्स काय करू शकतो, तयार करू शकतो. So now we are going to discuss the second part, that is the characterization, and it is very important part. आतापर्यंत आपण काय बघितलं की हिस्ट्री बघितली, what is mean by nanomaterials, what is their history, which is the invented this nanomaterial or nanotechnology or nanoscience. Then we discuss about the synthesis of nanomaterials, different types of the processes are there. So their optical properties, we discussed the semiconducting and metallic nanoparticles that and their properties, their characterizations, and how to distinguish this one metallic and semiconducting nanomaterials. Then we discussed the synthesis of nanomaterials, the collider routes, then hydrothermal soldier methods, chemical reductions method, electrochemical or electrodepositions method, CVD methods. So these are the synthesis of nano materials. Biological synthesis सुद्धा आहे, physical synthesis सुद्धा आहे, but that is not included in your syllabus. Okay. So now we are going to discuss the very important aspect regarding the nanotechnology or nanomaterials or the nanoparticles. Okay. सो नॅनो टेक्नॉलॉजी किंवा नॅनो मटेरियल्स मधला सर्वात इम्पॉर्टंट पार्ट जो आहे तो म्हणजे आहे की हाऊ वन्स वी सिंथेसिस दिस नॅनो मटेरियल्स. आता तुम्ही झिंक सल्फेट जर सिंथेसिस केला तर त्याला कॅरेक्टराईज कसं करायचं की हा नॅनो मटेरियलच आहे किंवा याची साईज काय आहे, याचं काय म्हणतात त्याला आपण मार्फॉलॉजी काय आहे. सो दिस जॉमेट्री मॉर्फॉलॉजी आर देअर, व्हॉट इज द साईज ऑफ दिस नॅनो मटेरियल्स, हाऊ टू दिस find out these nanomaterials with the help of this some characterization techniques. त्यापैकी एक दोन तीन टेक्निक्स तुमच्या सिलेबसला आहे. वन इज द एक्स-रे डिफ्रॅक्शन टेक्निक्स, सेकंड वन इज द सेम, and third one is the TIM. So these are the three techniques. Actually, number of techniques, characterization techniques used in the नॅनोटेक्नॉलॉजी. नॅनोटेक्नॉलॉजी मध्ये खूप साऱ्या टेक्निक्स आहे की ज्या कॅरेक्टरायझेशन करण्यासाठी आपण कॅरेक्टरायझेशन टेक्निक म्हणून यूज करतो. IR यूज करतो, मास यूज करतो, त्यानंतर DLS यूज करतोय, एक्स-रे डिफ्रॅक्शन्स, then we are using the beat technique also. Then we are using the different types of the zeta potentials we can calculate with the help of this. So these are the different types of the techniques we are using to characterize the nanomaterials. So the characterization method, it is used to know the size, structure, types of the atoms present in a nanomaterials, how these are the arrange of nanomaterials, what is their morphology, and how this explain the nanomaterials. We need to inform the like of size, crystalline type, and the composition. And some of the properties of nanomaterials. So जर आपल्याला नॅनो मटेरियल तयार झालाय आणि तो कसा आहे, त्याची साईज काय, क्रिस्टलाइन टाइप काय आहे, कंपोजिशन काय आहे, त्याची मॉर्फॉलॉजी काय, त्याच्या प्रॉपर्टीज काय, हे सगळं माहित करण्यासाठी आपल्याला त्याला कॅरेक्टराइज करायला पाहिजे किंवा कॅरेक्टराइज करून फॅब्रिकेट करायला पाहिजे. सो some of the methods we are using to characterize the nanomaterials. One is the method, that is the crystallographic methods. आता या क्रिस्टलोग्राफिक मेथड्स मध्ये आपल्याला एक्स-रे डिफ्रॅक्शन्स मेथड्स, दिस इज द व्हेरी प्रॉमिनंट मेथड्स यू आर युझिंग टू characterize the nanomaterials. Neutron diffractions, electron diffractions methods. So these are the methods to use to know the particle size and types of the structure. So out of these three, the X-ray diffractions method, it is prominent methods which used to characterize the nanomaterials, and from these methods, it is know the particles, what is their size and types of the structures. Second one is the spectroscopic methods. So these are the methods like your UV visible, IR absorptions, or this FTIR. Then your AS, atomic absorption spectroscopy. Then ESR, electrons spin resonance spectroscopy, and nuclear magnetic resonance spectroscopy, that is NMR. So these are the methods, or these are the techniques we are using to characterize the nanomaterials. And from this spectroscopic methods, we are come to know the chemical state of analysis or chemical structures of your materials. Whatever chemical present in your materials, so that is known with the help of this spectroscopic methods. Their electronic and other properties of materials we can know about this by these techniques, right? And next technique, that is the microscopic methods. So these are the very important methods for the characterizations of nanomaterials. So crystallographic X-ray diffractions and this microscopic methods, it is very important methods, like your optical microscope, same TEM, STM, AFM. So these are the scanning electron microscope, transmission electron microscope, and this scanning transmissions microscopy is there. Then atomic force microscopy is there. So these are the methods. It is very important to use the characterizations of nanomaterials, and from these methods, we are comes to know the morphology, size of nanomaterials, then structure of their nanomaterials, and images of atomic level. So this is very important characterization technique of nanomaterials. नॅनोमटेरियलच्या खूप महत्वाच्या टेक्निक्स आहेत. जसं एक्स-रे डिफ्रॅक्शन आहे तसंच हे आहे. डीएलएस आहे, बीट आहे. So these are the techniques. These are the techniques. It is a supplementary techniques, but this is the basic technique which is used to this nanomaterials. UV visible, this is very important. X-ray diffraction, same TEM, STM, and AFM, then DLS, all these things, all the techniques are very important techniques to know the nanomaterials. So, this is the electron microscopy. We are going to discuss the technique, that is a characterization technique of nanomaterials. So before discuss these techniques, we are first we discuss the X-ray diffraction techniques. So firstly, we discuss the X-ray diffraction techniques, and then we discuss the microscopic technique, right? That is same and TEM. So X-ray diffraction techniques or XRD methods, this is very important methods, and it is one of the most extensively used technique for the characterization of nanoparticles or nanomaterials. Typically, this XRD provide the information regarding the crystalline structures, nature of the phase and lattice parameters, and the crystalline grain size of the nanomaterials. XRD diffractions आपण बघितलेला आहे solid state chemistry मध्ये. So X-ray diffraction is the methods of X-ray crystallography, and in which the beam of X-ray strike the sample, that's crystalline solids, and which is land of the piece of film or other detectors to produce the scattering beams. जे आपण बघितलेले आहे की क्रिस्टल रोटेटिंग क्रिस्टल्स मेथड्स आपण बघितले, पावडर डिबेचरर और पावडर मेथड्स आपण ते बघितले एक्स-रे डिफ्रॅक्शन्स मध्ये. आणि लॉ पॅटर्न्स जो आहे, सो दिस एक्स-रे डिफ्रॅक्शन्स इट इज गिवन बाय द लॉ, दिस वन ऑफ द सायंटिस्ट, हे आपण ऑलरेडी बघितलेलं आहे की त्यांनी हे का एक्स-रे डिफ्रॅक्शन्स का, कारण द वेवलेंथ ऑफ दिस एक्स-रे अँड the distance between this, it is same, that is 10 raised to power minus 8 to 10 raised to power minus 10 like. So the X-ray diffraction patterns, this is the methods are used to characterize the nanomaterials, right? सिम्पली आपण एक्स-रे त्यावरती स्ट्राईक करतोय आणि तुमचा जो सॅम्पल असेल तो काय करतोय, एकतर स्कॅटर करतोय, ऍब्सॉर्ब करतोय किंवा रिफ्लेक्ट करतोय. So out of this, the scattered beam we are using, and that's beam scattered or the reflected beam, which is observed or appears on the photographic plate or the photographic film. त्याच्यावरती appear होते, and we can find out the angle, their angle, त्याची ह्या सगळ्या गोष्टी आपण काय करतोय, फाइंड आउट करतोय, and we can discuss the one equation, that is the Bragg's equation, and on the basis of that we can able to find out the crystalline size or grain size or this lattice parameters. Okay, so these beams make a diffraction patterns of a spot, and the strength and angle of this beam are recorded as sample is gradually rotated. So this is the methods were, yeah, very well known. That is the rotating crystals. That is diffractions methods. So these types of X-ray diffractions, it is the methods having some types. So that investigation the structurals or the crystal structures of the various compounds, solid compounds, like a law photographic patterns methods. This is just like a two methods, that is a transmission method and back reflections methods. Second one is the Bragg's X-ray spectrometer methods and rotating crystal methods, powder or debacher methods. So these are the methods, X-ray diffractions methods to investigate the structure and the crystal structures of the various solids, compounds or the nanomaterials. Okay. So these are the methods we are using. The equation, that is the Bragg's equation, or if it is called as the Bragg's law. So that the Bragg's equation in lambda is equal to 2d into sine theta. So how this equations is used to find out with the help of these methods, Bragg's or this rotating or the powder or debate error methods, this X-ray diffractions, these are the methods. So out of this one of the methods are we are using to characterize the nanomaterials, but so all these methods are using these equations. या सगळ्या मेथड्स मध्ये आपण हे इक्वेशन यूज करतोय आणि याच्यावरून आपण अँगल काढतोय, त्याच्यावरून रिफ्लेक्शन्स, अँड देन वी कॅन डिस्कस द लॅटिस पॅरामीटर्स अँड देअर प्रॉपर्टीज ऑफ युअर मटेरियल. So just I'm going to hear the one video, and just so this video, it is see this video, it is So so this is the video which will be find out the n lambda to be sine theta. This is the Bragg's equations. How it find out? This is we discuss in the solid state chemistry, right? So and how this Bragg's law or the this Bragg's equation is used to find out the uh, lattice parameters. This is very important things. That is the X-ray diffraction patterns we got, right? So here, this is the X-ray patterns. This is the X-ray diffractions patterns, and from this X-ray diffraction patterns, we discuss